Okay. Let's see if we can get things rolling. So in our last exciting Java class, we intimated that we would start to work with threads. And so with threading, I had some assigned reading, and in the chapter on threading, we had a number of interesting and wonderful topics. Did you all have a chance to do the assigned reading? You did. Okay. I noticed there are some people who are missing here from class, and I'm having difficulty doing the recordings. So if you're going to be missing from class, you may want to consider, asking someone for notes. I would say that some people have said, "Oh, professor, I didn't come to class, and therefore, And I'm like, well, a missed class is not an excuse for missed work. So you must attempt to get a makeup on the work. And I don't normally take attendance, but I do like to see some participation. So what I did was I printed out your pictures with your names. So now I know if you are here, you see, and I can even call your names and ask you questions, you see. And that means that I am going to go through the list alphabetically, and as I call you, I put a little check next to your name, and then I can ask you some questions. Isn't that fun? It will encourage class participation, you see, because last time I said, you cannot sit like lumps on bumps. I don't know if you remember my saying that. So now you must be ready for your comeuppance. Right? And so what this means is the professor will be calling on you, and this should keep you on your toes, which means you have to keep up with your reading. Abuja Abhinav, are you here? Not here? I can mark you absent? Abuja, absent? Too bad. Miton. Yes. You're here. Good. So I can mark you here. That's good. If there's a bunch of A's next to your name, it would not be good because it will be reflected in your grade, and the A's will not equal A. You understand? Mitun, I have a question for you. When you make a new instance of a thread, does it start to run?
Yes.
Okay. That was a yes or no question, and you answered yes. And everybody here in the class heard it. And it's very good that you participated, and I wouldn't grade you badly for that. However, your answer was incorrect. Yeah, making a new thread does not start it to run. First, you have to hit start. So you see the thread here has been instanced, but the thread is not running. You have to hit start, you see. Now, Alamura Venu Gopal Reddy, are you here? Yes. How do I address you? Vinu. Let me just write that down. Vinu. So Vinu, will the thread start to run after we hit start? No. That's a correct answer. Now, why won't it start to run after you hit start? It seems like it should start to run. Why won't it start to run? Why is that? You had a 50-50 shot and you won, okay? You got the big lottery thing here. And now the money comes raining down from heaven. But unfortunately, we all have other questions that go with it. Let me help you out. Getting a start invocation on a thread makes it ready to run. But the thread scheduler is looking at the list of threads and will not allocate resources to the thread to actually run the thread until the resources are available. So when threads are run, they're run by a thread scheduler. And the thread scheduler invokes the run method on each thread. So each thread has to have an associated callback or run method. So there's a life cycle for threads. Threads are born when they're instanced. Threads become ready to run when you hit start. Threads start to run when the thread scheduler gets to them. The threads, once they are finished, are returned to the heap. So then the threads die. So this is called the life cycle of the thread. And there's a little diagram of the life cycle of the thread in the book, which ostensibly you all read, right? No. Maybe not. So let's go on to the next person. Kushik. Are you here? How do I address you? Kushik is Kashik. Kashik. So Kashik, I have a question. How many threads can you run at the same time? 2. How did you get 2? There's the main thread of execution, that's true. Well, let me ask you this. Do you suppose there would be some sort of an error if we tried to run lots of threads, like, I don't know, 100 or 1,000? Kashik says we can only run 2. I don't think that's correct. So let's try and run lots. I like this idea. So what we'll do is we'll do something multi-threaded. We'll call it the thread tester. Let's see how many we can run, I think, with our little thread tester. And so what we'll do with our little thread tester is we'll have a main method. And then I would like to have lots of threads. Maybe the number of threads is not known. Let's start with an integer n and set it equal to a number like 100. And then we'll put in a for loop for integer I equals 0 while I is less than n, I plus plus, and then now I think I should make some new threads. Thread t equals new thread, new runnable, public void run, and now I have to start the thread. T.start. And what I'll do when I run the thread is I will print out something like the thread number. Quote, thread number equals, end quote, plus I. Oh, what could be wrong here? It's accessed within an inner class, therefore it must be declared as final. Okay. So what can I do here? I have an inner class. This is a nested reference. We've talked about nested references. This is an anonymous inner class. I will address the next person in line, Anna Mali Satyaraj Mirnalini. How do I address you, please? Say it again. Mirnalini? Mirnalini? So we just use this. Mirnalini. And so what should I do here to fight this little red mark that my compiler is complaining about? He says that these things have to be declared final. What can I do about it? Can I declare my integer I final? because it doesn't seem like it can be a constant if you want to increment it. Yeah, I can make it final? I don't know about that. If you make it final, that makes other things happen, like you can't increment a final number. Finals are constant. It's not a variable. Someone said make it static, but I don't think that will help me either. Any other ideas? Make it public. No, that won't help. Any other? It's an anonymous inner class. Hint, anonymous. Do you suppose maybe it would be better if it wasn't anonymous? Could we make it non-anonymous? If it's not anonymous, what must it be? It's either an anonymous inner class or it's a blank named, right? You weren't saying that, were you? Named inner class. So what I'd like to do is somehow convert this into a named inner class. That sounds like something we should do. How about this? How about if we take the whole thing and extract it to a method? We'll refactor it and extract a method, and we'll give it the name getThread. So now the thread has a parameter which is declared as final. A copy by value will be made. The red marks have gone away. This will let me get any thread you want, and the parameter I will be passed in. It's still an anonymous inner class, but it's inside of this little static method getThread. And now I can create 100 different threads, and each time I get them, I will start them. And they should start running pretty quick and then end, and I should be able to see them whizzing by in my console. Badam, you're here. How do I address you? Is it Badam? Is that correct? Badam. Badam. So Badam, I have a question. How many threads can I run? I don't think that Kashik was correct when he said 2, right? Because I already ran 99. How many threads can I run? Many threads. More than 100? Can I run 1,000? Yes? Sure, why not? Want to try and run 1,000? What could possibly go wrong? So we'll run 1,000 threads. Can that be okay, do you think? Nothing could, I mean, would you start 1,000 processes on your Windows computer? No, but they're not processes, right? They are threads. Are they all running at the same time? No, because they're not even coming out sequentially. You can see they're starting at different times, and so they're not ending with 999. And they're running asynchronously with respect to one another. I'm going through my little list here. There's more than one bottom. Is that possible? There's a bottom Raul, and then there's a bottom ready. Bottom, is there a ready? That you're the ready? Oh, so then you're the, okay, so I got you guys mixed up because there's 2 bottoms in the class. So bottom in the back. Bottom in the back. I have a, and we're going in order, so the bottoms are together. That's good. We'll get those bottoms out of the way. So the question I have for the bottom in the back, which is actually bottom, I have to give you a different address. Raul. Raul. Can I call you Raul? Is that all right? All right, let's do that. That way I don't have 2 bottoms answering. So Raul, I was wondering if you could tell me, please, how many threads can I create, do you think? I've done 1,000 so far. Kashik said 2, but obviously more than 2, and maybe more than 1,000, huh? How many threads? You think I could do like maybe 7,000? Do you think that would be okay? Huh? Why not? Why, infinite number? Infinite number? Oh, I don't know about that. What would be the reason why we couldn't do an infinite number of threads? Anybody like to guess on that infinite number? I can't really count to infinity, but I can count to more than 7,000. Suppose we just put a 0 in there and run it again. You think we can do 70,000 threads? Something's bound to go wrong, right? What do you suppose could go wrong? Ooh, it's very nice. It ran. Not only did it ran handily. I think what would happen here, if the threads didn't terminate in a quick way, is we would have too many threads coexisting with one another, and then you would have a problem. Let's try and sleep a little bit. Thread.sleep takes an argument in milliseconds, so we'll have each one sleep for 1 second, and then when a thread.sleep is invoked, you have to surround it with a try-catch block or declare the interrupted exception in the throws clause. So this will sleep for 1 second. That's 1,000 milliseconds. And so it won't start running threads until a second worth of creation, thread creation. So if you try to create 70,000 threads, eventually I think you're going to start to run out of memory. And it should start throwing little red exceptions, although I don't see them. I think it's just kind of died here. Oh, there it goes. It finished. Wow, how about that? So is it possible you can run infinity? Here, is that infinity? 700. Now, that's less than infinity, I'm sure, but still, it's a big number, 700,000 threads. Now, imagine if you're running Windows, and then you go live with your Windows program, and you get 700,000 hits on your website, and the 700,000 people are trying to fill up their shopping cart, and they're all doing it at the same time, and each one creates a process. And now there's 700,000 processes running under Windows. Do you think Windows would like that? No. What will Windows do? Crash horribly, right? Your programs will die, your operating system will croak, and your website will go down. But you will have tested it, it will have worked, but it will not. Oh, look, it says too much output to process. Well, that's all right. What do you think would happen with tasks in Windows that makes them somewhat different from threads in Java? How come I can make 700,000 threads in Java, but I can't start 700,000 processes in Windows? Why? Oh, I have to ask someone. So let's see now. Sanja? Yes. Is that the correct form of address? Yeah. Sanja. Sanja. What's the difference between threads and processes? Memory, that's key. Yes, threads run in shared memory, but processes under Windows run in protected memory. So what that means to me is that I can crash Photoshop, but that Microsoft Word, which is also running, shouldn't crash. Because even though Photoshop is writing to its own memory area, we swapped out protected memory where Photoshop lives. And then when it's time to run Word, we swap Photoshop into the virtual memory and swap the Word back into the present memory. So what we're doing when we have protected memory is we must swap the memory in virtual memory out to the disk. If you have a thread, you don't have to worry about that because they all share memory. All the threads share memory, and the memory they share comes from the Java virtual machine. So when the Java virtual machine runs out of memory, all the threads die within that virtual machine. So what is happening here is that we're launching many hundreds of thousands of threads. And the virtual machine that we're using the resources from is just one virtual machine running in its own protected memory, and it's the Java virtual machine. So what this means to me is that I can have many, many hits on my website and not get my computer to grind to a halt because it's not allocating tons of memory for each new thread. Very small amount of memory. But it also means something else. It means your threads all have to play nice with one another. They can't clobber each other's data structures, or else they will not behave in a predictable way. So you have to be careful as a thread programmer. You have to make sure that your threads behave as good neighbors, but you don't have to worry about using up lots of memory. But there's more. When you switch between one task and another, it takes a lot of time because the memory has to be stored into the hard drive. How much slower is a hard drive than system memory? Oh, I have to ask somebody. Let's see. Punya, are you here? Chandrala Punya, not here, absent. Varun, Venkata, missing. Rakesh, missing, in action. Oh, this is terrible. Akil. Ah, you're here. Good, good. How do I address you? Is Akil correct? Yes? So Akil, I have a question. Oh, look, I ran 700,000 threads. How about that? Took a while, but that's okay. Didn't crash. Well behaved. 700,000 is a lot. My little computer is only a laptop. For 700,000 threads, I think you should use a server. So I have a question, Akil. With all of these threads running, would it be different from running all of these things as processes in Windows? And the answer is yes, we know, because they have different thread memory requirements. But what about switching between one thread and another? Would it take longer, or would it be slower than switching between one Windows process and another? It would be slower? So when switching from one Windows process to another, that's slower, right? Yes, okay, that's true. And the reason why is because you have to swap the memory into the hard drive. And so then the question is, how much slower is hard drive memory than system memory? We know hard drives are slower than RAM. But how much slower is a hard drive? You have any idea how long it takes to access a hard drive? Could be, is it days? Seconds?
It will be in seconds, obviously.
Milliseconds? I think milliseconds, huh?
Yeah.
Millisecond access time for hard drive, nanosecond access time for RAM. For RAM. Now, nanosecond, that's 1 times 10 to the minus 9. And millisecond, that's 1 times 10 to the minus 3. So the difference between 9 and 3 is 6. So 6 orders of magnitude. That's 1,000,000 times slower. So when you are starting to do I/O to the hard drive, you must be prepared to do I/O to a device which is 1,000,000 times slower than your RAM. But maybe you have, perhaps, make up a number, 4 gig, 16 gigs of RAM. How many gigs of hard drive do you have? Could be a terabyte. Right? So you could have 1,000 times, you could have 1,000,000 times more disk, but it could be 1,000,000 times slower. So big numbers in terms of storage space, but very, very small numbers in terms of performance. Right? So these are the things that you're trading off when you're starting to use different storage devices. RAM is important because it's so much faster, but you don't have a lot of it. And it's volatile because when you turn off the computer, it goes away, but the hard drive will still be there. So now I've got this problem. When I switch from one thread to another, I am switching context of execution. When I switch from one process to another, I am also switching context of execution. But I have a low overhead context switch in the thread. So because I can switch from one thread to another very quickly, I can essentially move from one job to another without a lot of overhead. When you think about the overhead for your context or your focus of execution, think of it a different way. You're working hard at your desk, and your boss comes over with the sheaf of paper and throws it on the desk and says, make this your top priority. So by the afternoon, this is done, and now you try to get back to where you were, and you can't remember what you were doing. That's a high overhead context switch, right? Because you got interrupted. Well, that's the same way it is in the computer operating system when you have to take an application and swap it out to disk and then start working and then swap it back when you're wanting to switch back. If the time allocation for swapping is higher than the amount of time that you can spend doing the job, you are doing what's called thrashing. You're thrashing to the disk. If you are in Photoshop and you're trying to do image processing without enough RAM relative to the size of your image, you will see the disk I/O if there's a light, and it'll be going tick, 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 and you will be making no progress. You're thrashing to the disk. So this is one of those things you shouldn't have to worry about if you're doing threading. Threading gives you much higher performance computing when you're dealing with multiple things that are trying to work at the same time. But when you think about it, it's not true concurrency, right? Because why? Because even when you're working with multiprocessing, multitasking, or when you're working with multi-threading, you're simulating multiple things happening at the same time. The thread scheduler takes turns between one thread and the other. The task manager takes turns from one task to the other. But if you want true concurrency, then you need multiple CPUs. So if you have multi-core CPUs like dual-core or 8-core or network of workstations, then you can have true concurrency. The other things only simulate concurrency. So true concurrency, we call that multiprocessing. But when you try to simulate the true concurrency with many tasks, we call it multitasking. And if you try and simulate the true concurrency with multiple threads, we call it multi-threading. Multi-threading, multitasking, multiprocessing, all three are very different things, and they represent different approaches to programming and computer architecture. So this is kind of an important sort of holistic lesson about computing, because if you have multiple CPUs, you truly can do multiple things at the same time. But in general, as a Java programmer running threads, you're really just doing one thread at a time, even though it seems like many are running at the same time. How's that grab you? Multi-threading is not the same as multiprocessing. True concurrency is not the same as simulated concurrency. Got that? Yes? Good? Yes? So now I've got this other interesting thing going on. If you have a thread, right, that comes back, do you suppose maybe I could get a handle to that thread T? Suppose I change my code just a little bit so that it returns the thread. Then when the new thread is created, after it's been started, I can say return T. And now I have a new design pattern, one that gets instances of threads for me. What design pattern is that? Factory, yes, excellent. So this is the factory design pattern, and now I have access to each one of my little threads. And it's a thread factory. I can turn this down a little bit. Now for each one of my threads, I have an option which enables me to change things about it. I can parameterize how the thread is treated. T.set priority. So now with the priority on the thread, I can give it a minimum priority or a maximum priority. Thread dot maximum priority. Or if I like, I could give it a minimum priority. Thread dot minimum priority. And then if I want to, I can see what it means to have minimum priority. That's priority 1. And I can also see what it means to have maximum priority. Oops. And that is priority 10. So then I say, this is a very interesting thing that's going on. Suppose I let the even numbers have minimum priority, and I let the odd numbers have maximum priority. I can do that. I'll put up an if statement that says if I div2 equals 0, then priority is maximum, else t.set priority thread.minimum. Now when I run the programs, some of the even ones should get done at a different time than the odd ones, I should think. But with only 70 threads, maybe it won't make such a big difference. I can see the even ones got done last, and the odd ones got done a little bit sooner. So even ones got wrapped up at the end. How about that? So I gave priority to the odd ones. Pretty neat. So you can change priority. How about the name? Well, I guess I could change the name too, right? As a matter of fact, when the thread is created here, I could set the name. And I could give it the name I, or perhaps plus thread number end quote plus I. There. So then when the thread runs, instead of printing out thread number I could just say, let's see now, get name. But that doesn't seem to work. Why is that, I wonder? Why? Oh, I have to call on someone? Praveen. Chowdhury? Missing? Jacob. Do I address you as Jacob? Is that correct? Rejoy. Okay. So can you tell me, please, how do I get rid of this red thing here? Why can't I get the name of my thread, Rejoy? Why is that? I got a bug. Can you help me fix my bug? Well, get name, that's part of the thread class, and I'm making a new runnable. Do I have access to the methods in the thread class when I make a new runnable?
Yes.
I do? How would I get access to them?
The same thing.
This dot? Now that doesn't help. Thread dot? That doesn't help. What can I do? Get something? Sorry? Thread runnable. I'm sorry, I don't understand what you're saying. If I want the name, here I set the name, but I had to be outside, right? Because T is where you have access to the thread. Why can't I gain access to the thread's set name and get name? T.getName, I'm sure that's there. Here, if I go over here, I should be able to get the name. There's the name. So that's there. How come I can't get the name from inside of the thread class? Why is that? Any ideas? No ideas? Say it again? Called a thread object. How do I do that? You mean like super? I don't think I can get the thread object. I can't gain access to T because T hasn't been created yet. I can't get access to the outer class. I'm inside of a nested reference data type. So since I'm part of runnable, I'm not part of the thread class. So to gain access to the outer class doesn't seem to me to be possible unless you want to start to convert the anonymous class into a named class. How would we do that? You want to extend it, huh? That's a good idea. Is it possible to replace anonymous with named? This doesn't look like it will do it. Extract doesn't look like it will do it. I think you're barking up the right tree. Refactor this, and now I'd like to replace anonymous with named. Come on in. But it doesn't give me an opportunity to do it. So for me to do it, I think I have to write a new class that subclasses the thread and takes a runnable interface. Here it is. Convert anonymous to inner. So what we'll do is we'll make our own little runnable element. And now we've got a runnable class. And now if you want to, you can get the name. But it's very clear in here why getName would not be available to you, because getName is part of the thread class and it's not part of the runnable class. So getName cannot work. What do you think of that? Right? You can't use getName here. Not unless you pass an instance of the thread into runnable. However, if you wanted to, you could have a name, myRunnable. It could have its own name. Why not? And then you could get the name from myRunnable. That's legit. So let's assume that you want to be able to get the name. Public string get name. Return thread plus I. And now, if you want to, you can use the runnable instance, and we can extract a method over in here. And if you want to get the name from my runnable, you can set the name for your thread and say it's myrunnable.getName. And now it's legitimate. And you've kind of addressed what you wanted to do, make it so that runnable things have their own name. Then you can take that name and grab it from the runnable thing and put it into the thread. What do you think of that? So when it runs, will it be able to get the name? And the answer is yes. He's got his own little getName method. And now he can have a runnable element which prints its name. Naveen Kumar, are you here? You are here. Oh, great. Naveen Kumar. Naveen Kumar, I have a question. How do I address you? Is that the correct way to address you, Naveen? Yeah. Should we like to, we may like to make it so that runnable things have their own priority. How would we associate a priority with runnable things? And then inherit that priority for our threads. Any ideas? Well, we know priorities must be between 1 and 10. And we're given a number, I, and I is an integer. So suppose I wanted to set the priority from I. Couldn't I use the mod feature and then use I mod 10 and set my priority? What do you think of that? So what would I do to implement my wonderful new algorithm for setting priority? Well, suppose I start you off and we make a little integer called priority. And we set the priority equal to the thread, whoops, let's just set it equal to 5. That's the normal priority. And then when I comes in, we'll make the priority equal to I mod 10. Oops. Mod 10. But that could be 0, so I'll say plus 1. And then what we'll do is we'll make it so that the mod has priority, that is arithmetic priority, and there's a problem. And the problem is somehow my trackpad screwed me up. So now I've got priorities ranging from 1 to 10, inclusive. I also have them set to the priority element here. So now what do I do? Vinay Kumar. Ah, you're here. Is that the correct form of address, Vinay Kumar? Vinay Kumar, what do I do now? I want the priority to be set on the threads from the runnable elements. I already have the priority being contained by my runnable. I would like to be able to gain access to it. So what's my next step, do you think? Any ideas? How would I gain access to the priority from the thread? Runnables know their priority. We've set the priority. So what do I do to communicate that priority to the calling thread? How about this? I'll get you started a little bit. We'll put in a public method that says get priority, and then we'll just return the priority. Okay? So now I've got my thread over here. I'm making new threads, right? And they're being made from my runnable. So now I see I can set the name. Before I start the thread, how about we set the priority? What do you think of that? Any thoughts? What should I be doing here? Yeah, I want to gain access to the priority in the thread, so I can do set priority. Now, where am I going to get the priority? Vinay Kumar, right? Yeah. So I got to go to my runnable and go get priority. So now the threads that are being created are getting their name from my runnable. They're getting their priorities from my runnable. And then when you do t.start, they're going to start with their own priority from my runnable and their own name from my runnable. And then when they run, my runnable is going to print out its name. Be using getName. So let's try and run like 70 threads and see how that goes. And that seems to work. And all the threads have different priorities, so they're all running at different times. What do you think of that? Okay? We're there? Hari Krishna? Is that the correct form of address? Hari Krishna? I think you're very famous. So I have this idea that I've got the ability to create lots of threads with many different priorities, perhaps 10 priorities. And we've seen that we can create many threads. What would happen, do you suppose, if we wanted the threads to sleep an amount which is equal to some function of their priority? What would you do to implement that? Let's assume you wanted to take the priority number and multiply it by the number of seconds. So if it's priority 10, it takes 10 seconds. If it's priority 1, it runs in 1 second. How would you implement that? We know that thread.sleep takes a number in milliseconds, and there are 1,000 milliseconds to a second. So if you want it to sleep for 10 seconds, then that number should be 10,000. And if you want it to sleep for 1 second, the number should be 1,000. And we know that the number should be a function of the priority. So what should I be doing here? Yeah, we want the priority number so I can get priority. And then if priority is number between 1 and 10, it's only going to sleep between 1 and 10 milliseconds. But we want it to sleep between 1,000 and 10,000. So what do we do now? How about we multiply by 1,000? So then when priority comes in as 10, this will be 10,000, which will make it sleep for, some of these threads will sleep for 10 seconds, and others will just sleep for 1 second. But it seems like they're pretty much finished right away. Oh, the printing should happen after the sleep. That's key. So now they won't start printing until after the sleep is done. And you can see they're gradually waking up. The 5-second ones, the 6-second ones, and finally the 10-second ones. So with them gradually waking up, we can choose when to start the different threads. So threads become ready to run when you hit start, but they do not start to run until the thread scheduler gets to them. If the thread scheduler hits a sleep method, the thread scheduler puts them in the wait queue. When the wait queue wakes up, then the threads begin to run again. So in the life cycle of the thread, there are wait queues which allow the thread scheduler to take the threads and put them aside while they are in sleep mode. Okay, why do we care about threading? No, I can ask somebody. Ahmed Mukhtar, are you here? LNU? I don't know how to pronounce LNU. Mukit? Mukit. He's not here, absent. Well, how about Prashanth? Is that a correct form of address, Prashanth? Prashanth, can you remember my question? Because I just forgot. I mean, to be perfectly frank and candid. I'm looking at this code here on threading. Do you remember the question? No? Shoot. We'll get to you in a second. So let's see now. Oh yes, I remember now. Why? Why do we need threading? Why are we doing this? It's threading. It seems very complicated to me. Why? Why do this? What possible reason could there be for such complexity? Things should be as simple as possible, but no simpler. That's what Einstein said, right? So this is the most complicated thing I ever saw. Why should we have this? C doesn't have this. Multiple what? You need to finish your sentence. It sounds like you're onto something. You just said multiple, and then you stopped. You got to give me something to go on here. Just multiple. If you have multiple things that you're trying to do at the same time, maybe multi-threading would be good, but look I can do 70,000 threads here. I can do 700,000 threads, right? I can make as many threads as you like. So it can't just be several things at once, apparently. There's a reason for having so many, and what am I doing with these threads? What could I do other than doing multiple things at the same time? Well, suppose you're trying to read from the network, and the network is stalled, or it's slow. You can have that running in the background as you read from the network. You don't want to block your primary thread of execution as you're downloading. So if you want your program to be alive while you're doing something that takes a long time, you can launch a thread and do the I/O in that way. That way you're not I/O bound. If you need to allocate a resource, open a serial port, could take a while. Use a thread. Get it running in the background. That way you're not blocking your primary thread of execution. So all of these things lend themselves nicely to threads. Dinesh. Is it Manakonda? No, Dinesh. But Dinesh is the correct form of address. You're up. I don't know the question yet, but I will have one. So I've got this wonderful framework now for threading, and threads give me all of these abilities. I can set the name, I can set the priority. What other things can I do about threads? It says here, I can set the daemon. What is DAEMON? What is the daemon? What is a daemon? What is it?
It's a type of thread
Which
which
desires
true or
true or
false.
false.
Oh. Does it stand for something, daemon?
Just, it's a kind of thread.
That will execute.
Disk Access Execution Monitor, daemon? Isn't that right? It actually stands for something. I can make it true or false. Oh, I've been infected by malware. I think it stands for disk. It's supposed to stand for Disk Access Execution Monitor. But he's not telling me.
It is a thread that does not prevent the JVM, but it runs background.
Yeah, it will continue to run after the main thread of execution is done. You can have a daemon thread or a user thread. The virtual machine exists when the threads running are all daemon threads. This method must be invoked before the thread is started. If it's a daemon thread, it will continue to run even after the main is dead.
Like garbage collection.
And you have to run it before the thread is started. So the daemonness must be, right, it's not running at all. You make it false. Then it will run with the main thread dead. So the main thread can finish, but the daemons will keep going. Or the non-daemons will keep going. Yeah, there it goes. So the main thread could be done. But the other threads will keep going. So the main thread of execution is launching 700 different other threads. It can be finished very quickly, and then the others start. And you can see done. I don't know if you saw the done at the top. But there. Main thread was done, but the other threads kept going because daemon was set to false, which is by default. So that's the daemon. Sindhu. Sindhu Maru? Sindhu? Not here? Absent? Oh. Ashrith? Is that the correct form of address, Ashrith? You're up. Don't know what we're doing yet, but you're up. So I've got these interesting things going on with threads. I think maybe we're getting a little bit deep into the threading system. T.get group. Yep, get thread group. So threads have groups. That's interesting. A thread group returns a thread group which the thread belongs to. This method returns null if the thread has died. Okay. Oh, and it's of type thread group. That sounds good. Thread group. TG equals get thread group. Sounds good. So Ashrith, what do I use the thread group for, do you think? Any ideas? I got a thread group. I can determine how many active threads there are in the group. So what do I need them for? Any ideas? Oops. Guess you need a plus. Ashrith, I'm not hearing the words. No ideas? No? Can you give me a guess as to why you'd need groups? Here it looks like they're all in the same group. When I look at the count, I just see the count continues to increase as the number of threads is created. So the number of threads, as you create the new, all the threads are being instanced, and the thread count keeps increasing. So they're all in the same thread group. And then after you've made 701 threads in the thread group, it says, I'm done, and that's the main method, and now the threads start to run. How fun, right? So what do I need thread groups for?
I think it shows that which are active. Like,
Well, I can group the threads together. So I can have the main thread group, or I can have auxiliary thread groups. When I launch threads that are in a group, they can all inherit properties from one another, and that includes priority. So you can organize your threads into groups, and you can kill them all at once, or you can set them all null and return them to the heap. So having all the threads in a group might be a nice way to organize the threads. I don't see that being used a lot. It's a reasonably exotic thing to do. But if you think about it, if you hit Alt-Control-Delete and you start your task manager, you've got a lot of processes. And the processes all have names, and they have memory, which they're using, and they have priority, which you can set. And the same thing is true for your services. So it's possible that organizing all these things by group makes sense. You can even see how much memory and CPU usage is being used for your processes. So we could build such a thing just for threads and organize the threads and keep track of the resources which they need. So having lots of threads all running at the same time might be something we have to be concerned about, something we need to manage. So having a thread manager might be a perfectly reasonable thing for us to want to do. When you're making new threads, what other resources do we have to care about? Let's try Shruti. Shruti? Yes. That's the correct form of address, isn't it? Shruti? Shruti. What other resources do we have to care about with threads? Threads must use up something in the CPU, right? What do they use?
Memory.
Memory, okay. So if they're using memory, maybe I should be able to find out how much memory I've got. So as I run this little program here and I get threads, how about we print out how much memory is available? So I'll try and do something like this. System utils dot get free or get memory. Can I get memory? How does one do that? Free. What does this mean? Free. A string that describes the Java virtual machine's free RAM. Let's see how that works. That's my own code. I should be able to refactor it by inlining the method, this invocation, keep the method refactor, and it says get the runtime, and then print get the RAM string. Get the RAM string. What could that do? Well, doesn't say much, does it? Runtime utils. What could this be? Gets the runtime, gets number of CPUs, runtime utils, get the RAM string, get free RAM. How does get free RAM work? Oh, runtime gets free RAM. So I've got this whole thing going on here where I've got my own little runtime utils. Goes to the runtime, it tells me how many CPUs I've got. Tells me the percentage of RAM that's free. Gets the total RAM. Get the free ratio. Sounds like it does quite a bit. Let's give it a whirl and see what happens. This is my own little utility. So that's done. Let's go to the top and see how the RAM is decreasing. So he says 56. 56 hasn't really changed much. But then he says 92% free. I think the amount of RAM it takes for 700 threads is relatively small. He only used up like 1% of the available RAM. So probably I could do, I don't know, 600,000-700,000 threads and not have to worry too much about using up all my RAM. So that's kind of interesting. You can benchmark how much RAM you're using. You can use a thing here I called system utils, which returns free, or you can use these runtime utils, which makes a new instance of the runtime. Let's see if we can extract the method here. So we'll do refactor, extract, method, and get print RAM string. Refactor, extract, method. I'll do it again. Oh, he doesn't like that. Cancel. There are limits to what you can do with refactoring. That's probably too much detail, but I like the idea of being able to monitor the threads, figure out how much RAM they're using. I like the idea of running a lot of threads and making sure I don't run out of RAM. I think if I'm going to run thousands of threads, I better know if I'm running out of RAM. I think I need that. But you guys, you're probably not going to run thousands of threads. And so now you've got an opportunity here, which I think is quite nice. You can explore, right, the ideas behind multi-threading. You can make lots and lots of threads. You can do I/O and use the I/O so that it's multi-threaded. And I think that's a very compelling and interesting idea. I'm going to put the thread subject to bed unless you guys have some questions about it. Yeah, that doesn't look like it's doing very much for me. So let's try and do another person. Or Shruti. Did I ask you any questions, Shruti? Not yet. So we still have you to, how about this? Can you think of an application involving graphics that might use threads?
Yes,
Hmm?
we can build
What would you implement?
graphics.
What kind of graphics? Any ideas? What would be a good application? Just any application involving graphics?
Drawing geometrical figures.
Okay, drawing geometry might be good. Geometric figures that are animated would be good. My first example is usually a clock. So if you have a clock that gets drawn on the screen, you want it to run in the background in a thread that wakes up every second and changes the time. So you can see it tick-tock. So a ticking clock, that's a good idea. I think we should try and make a ticking clock that displays, but before we do that, we have to know a little bit more about graphics. We have to have some idea about how we can do maybe some swing. So that's a little bit advanced, but not too bad. How about if we make a digital clock that every second runs and then prints out the time? That's a reasonable thing. If it's printing on a console, then we don't actually need any graphics. So let's make the text clock. The text clock is an interesting kind of clock. And what we'll do is we'll make it so that the text clock implements runnable. Okay. And now, because it implements runnable, it has to have a run method. And then when it runs, what we'll do is we'll put in a while loop. So it runs forever. We'll put in while true. And then what we'll do is we'll have it sleep for a second, and then we'll have it print out the date and time. S out, Control J, enter. New java.util.date. So that will create a date time instance, and then what we'll do is we'll have it sleep. Thread.sleep. We'll sleep for 1 second. And then what we'll do is we'll surround it with a try-catch block. And now I've got a runnable text clock, and I have to create a thread to run it. Bhargava, are you here? Yes, is that the correct way to address you? Bhargava? Did I say it all right? Bhargava? What do I do now? I've got a runnable method inside, I've got a run method inside of my runnable text clock, and now I want to run it in a thread. What should I do? You tell me.
Make instance of
You got to make an instance of it. Okay, so how do I do that? Well, I can certainly make a main method, right? Because I got to have something to run, and I need a thread. Thread T equals new thread. Now what do I pass in as an argument? You need something that implements the runnable interface. Well, doesn't the text clock implement the runnable interface? So if I put in a new text clock, that gives the thread something to run. And we know the text clock is going to be running, but only after we start the thread. So I have to say t.start. Now the main thread of execution is done. So I'll just print out done. But the thread will continue to run in the background, and it will print out the time every second. So now we have a very basic clock that wakes up once a second, prints out the time, and then goes to sleep for another second. Voila. There's not much graphics here, but at least we can see that the thread is running. What do you think of that? Good, right? Runs, works. It runs. Vaishali? Yes? Is that the correct form of address?
Yeah.
Vaishali? Okay, you're up. So, Vaishali, how shall I take my clock, my lovely little clock, and do something graphical with it? Do you have any ideas? What can I do to make the clock display on the screen? That's an advanced question. We didn't get there yet. That's probably the next chapter or so. But if I wanted to do that, I would have to make a new instance of a frame. I would have to show the frame, and I would have to draw a string, and then I would have to erase the string and draw it again. And then I could have a digital clock on the screen. I think that's not a good question because it's too complicated. I wonder if this does that. I see there's a stopwatch panel. Oh yeah, see, this is using swing. And now we can see I've got something displaying on the screen. If I hit reset, now it says 0 seconds since reset. So there's something counting in the background. Can you see it in the back? Yeah. But to learn how to do that, we have to learn about J-labels, and we have to learn about panels, and that's also kind of advanced relative to what we know how to do. So we'll skip that for now. So that's what I've got on threads. That was my chapter 13. What do you think about that? How do those threads grab you? Okay? Anybody with questions about threads? So then, Vaishali, how many threads can I create? Many. Right. We don't know. It depends on something. What does it depend on? Memory, sure. Yeah. If you run out of memory, you probably throw an exception at runtime. I have an idea. Suppose I wanted to create a giant array of threads. Oh, here's one called massive multi-threading. It looks like there's 5,000 threads. So I make 5,000 threads in an array, and then I pass the array into something that says start thread. And the run thread job thing, whatever that is, has a start thread method. And it looks like it makes a new instance of the run thread job thing. This is complicated. How about we do something new? Let's do something new. Let's make a lot of threads. I want to make a giant thread array. Java class thread array. Example. Okay? And what we're going to do here is we're going to start off with a thread array, TA, and we're going to start off with 7,000 threads. Whoops. That's pretty good. Pardue. Yes. Is that the correct one? Pardue? How many threads did I just create with this one line? None. That's correct. I only created placeholders for all the threads. So if I wanted to create the threads, what I would need to do is have some kind of a constructor. And in the constructor, I could loop through and I could say TA of I equals new thread of new runnable of public void run, and that'll create 7,000 threads. Yashwant, you're here. Great. Is that the correct form of address? Yashwant? So then, how many threads did I start, Yashwant? The answer is 0. None of the threads are running. All I've done is I've made new instances of threads. They're not even ready to run. I didn't start any of them. So what I need to do here is I need to call TA of I dot start. Now, how many threads are running? Yashwant. No, they don't run until they become invoked by the scheduler. So starting them just makes them ready to run. So none of them are started until you hit start, and none of them are running until the scheduler gets around to allocating resources for them. Oh, you can know what you could do is you could print out the date. New Java util date. Okay, so let's try Surya Vamshi. You're here. Is that the correct form of address? Yeah. So then, Surya Vamshi, what do I do in order to test my thread array example? What's my next step? You tell me. It's not going to run the way it is now, is it? I have to do something, don't I? What do I do? You tell me. Surya Vamshi, sitting in the back does not allow you to escape my attention. I see you. So you can sit in the, you can run, but you cannot hide. Although others are running, I think they are hiding. So I need a main method, don't I? What should I do in the main method? This is where people in the back are getting their comeuppance. Raja. Is Raja here? Not here. Absent. Oh, okay. Rajendra. Rajendra Reddy Pura. Absent. Through my little list here. This is fun. Shravan. Did I say it wrong? Shravan. Shravan. So what do I do in this main method? You tell me. I'm stuck. Pretend I'm stuck. I know what to do, but you don't know, so you have to tell me. Guess.
You have to initialize new thread.
Yeah, I wanted to make a new instance of this thread array example. Let's call it TAE and set it equal to new thread array example. And now what do I need to do to make things start? Any idea?
You have to call.
It's a trick question. I don't have to do anything. It'll start on its own because the constructor has the same name as the name of the class, returns nothing, not even void, and upon construction, it will instance the 7,000 threads. Then it will print out the date on the 7,000 threads, but only after the start method is invoked and the scheduler makes it ready to run. So, what do you suppose will happen? Will it run out of memory? Will they all run? I think it'll all run. Yeah, it's running. And the done, you can see the main was done before the threads were done. They get done quick. If you like, you can put in a delay. Thread.sleep of 1,000, and then surround it with a try catch. So what do you think of that? 7,000 threads all sitting in an array. Why not? Starting whenever you're ready. And then they wake up. Sai Jivan Reddy. Jivan? Missing? Akila. Akila? Missing? Renu Kunta? No? Niharika? Okay, great. You're up. Don't know what you're doing yet, but you're up. So now I've got 1,000 threads sitting in an array. How many threads do you suppose I'll have in my thread group if I go to the thread group and get the count? I can do this even before I hit start, right? I can print out how many threads are in the thread group. I can go to TA of 0 dot get thread group dot active count. That'll be an integer n. How many is n? Well, it's more than 7,000, isn't it? Yeah, the main thread of execution, that's included too. So 7,001 maybe? But if they start at 0, perhaps it will just say 7,000. But there must be at least 7,000 as the number. Yeah. So let's try that. Quote, thread count is plus n. And now I think maybe we should see a number over 7,000, or maybe 7,000. I don't know how they count it. thread count was 7,001. So we include the main thread. So he starts at 1 with the thread, the main thread, and then he adds the 7,000. So there really are 7,000, and they're all in the same thread group. That's pretty slick. Let's see now. Kishan. Kishan? Missing? Vidya Sagar? Missing? Big Nata? Missing? Swati Siri? Yes. You're up. So those who are not here, actually it's quite interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? We're missing 13? That's a lot. I get emails from people saying, "Oh, professor, I didn't come to class." And I'm like, well, gee, you should come to class. Is Swati Siri the correct? Just Siri. Okay, Siri is fine. We'll just make it Siri. What do you suppose would happen if I added a couple or 3 zeros like that? Just guess. Yeah, I think it should run out of memory. I think so. Something bad, I imagine. You can't, someone said you can have an infinite number of threads, but I don't know if that's really true. Because look at all the threads we've created, 12,000, 13,000. Oh, some of them are starting to run. You know, when they start to run like that, once they're done, they're dead. And that frees up memory. So if the thread scheduler is running these threads, I think it's really running that many threads? It seems like it stopped. It seems like it stopped at around 14,000. Oh wait, there was a blip in there. Whoops. There we go. He's giving us a hint that after 14,000 my little laptop ran out of memory and just said null pointer exception. So that's kind of a, I don't know, a deal killer, right? We didn't monitor the memory, we just created threads, and clearly whatever happened here, it tried to recover. A lot of threads worked, but many did not. And we certainly didn't create 700,000 threads. That's an illusion. I mean, it lets you do it, you can write the code, Java won't stop you, but the runtime will. And well, it should, right? Because you don't have sufficient memory for that. So at some level, one could make a compelling argument that you were fairly irresponsible to try and allocate 700,000 threads. And in fact, if you're going to benchmark these sorts of things, it would be good to benchmark them on a modest machine with modest load, because probably you don't want to be allocating more than 7,000 threads. And if they're going to each get some computational load that's realistic, then maybe many fewer than that, because your CPU will become bogged down. So that was a good lesson on threads. What did you think? Did everybody kind of get a feeling for threads at this point? What I'd like to do is I'd like to take a little class time and do the surveys, the class surveys. And then I would like to remind you that we're having a guest lecture over in Banau 133. So if you want to come down, I believe they're having free pizza. So if you don't want to listen to the boring lecture from the guest, who I think is bringing interesting equipment about microwaves, then you can eat the pizza and leave. Probably it's okay to eat the pizza and leave, but it's not okay to take the pizza and leave. So let me stop this for now.